This hearing will come to order. Without objection, the chair is authorized to declare recess at any time. Good afternoon. Thank you for your understanding that we were on the floor in votes. Very glad to have you here. And welcome to everyone who is here and to our witnesses. We appreciate you being here today. In today's hearing, we're going to address one of the most important and rapidly evolving issues facing our ability to operate in space situational awareness. At present, the Department of Defense's public catalog reports over 20,000 space objects. And with the event of mega constellations and an increasing amount of players, space is only going to get more crowded. In fact, a June 2019 assessment predicted that more than 20,000 satellites would be launched into orbit by 2030 based on announcements of new planned commercial constellations. Space situational awareness allows us to track and monitor the number and location of space objects, how to characterize the space environment, and identify any potential collisions that could be avoided. A good example of the need for better space situational awareness occurred just a few weeks ago when officials were closely monitoring two dead satellites with interest and concern. The two satellites, one a NASA satellite and one an Air Force experimental spacecraft that was launched in 1967, were expected to pass extremely close to each other at speeds of 32,000 miles per hour. If these satellites were closer than estimated, it could have led to a collision, creating thousands of pieces of space debris that could have potentially devastating impacts on other operating spacecraft. Satellite and spacecraft operators need reliable space situational awareness to respond to collision threats, because a moving satellite or spacecraft involves time, money, and resources such as fuel, and the accuracy of situational awareness data, and the reliability of collision warnings are all things that need to be considered. The bottom line is that space situational awareness and ensuring the safety and sustainability of the space environment is an issue that affects our civil space program, our commercial space sector, and our national security space activities. And it's a problem we need to understand and begin to address now. Space is a critical part of our infrastructure. It enables our nation's commerce, agricultural productivity, banking, and many other aspects of our day-to-day lives. Imagery and data from orbiting weather satellites and precision navigational and location data from the Global Positioning System, GPS, are essential to countless aspects of national security and commerce. Threats to safety and sustainability of the space environment would have far-reaching implications for U.S. government, commercial, and non-U.S. operations in space, and our nation's reliance on space activities. Today's hearing and the testimony of our witnesses is a critical start to exploring this topic, because while the problem of space situational awareness is ever more pressing, how we manage it is equally important. This start must include a clear and thorough examination of the rapidly evolving nature of this issue, the broad range of stakeholders involved, and the international and legal aspects of the changing landscape of space situational awareness. To that end, provisions in the bipartisan H.R. 5666 NASA Authorization Act of 2020 began to scratch the surface on improving space situational awareness. Some of the provisions include authorizing NASA to carry out research and development activities on space situational awareness and orbital debris mitigation, directing NASA to conduct an SSA research and technology strategy, and directing the administrator and other relevant federal agencies to carry out international discussions and capacity building on orbital debris removal. Let's see if I can get that word out. The provisions in H.R. 5666 and today's hearing are what I anticipate will be the first steps in a series of subcommittee and committee activities on space situational awareness. Future subcommittee activities will need to consider the technical capabilities, authorities, and roles and responsibilities for effective, ongoing space situational awareness, data and information services. In closing, space situational awareness is not a U.S. issue. Space knows no national boundaries, and the solutions for ensuring sustainability in space must be international. However, leadership in this effort should come from the United States. We, in collaboration with our international partners, must shape the practices and behaviors of space operators we expect others to follow in ensuring the safety and sustainability of the space environment. Thank you, and I now recognize Ranking Member Babin for his opening statement.
Thank you, Madam Chair. Great to be here today, and thank you to all you witnesses. Today's hearing on Space Situational Awareness, or SSA, is a continuation of the committee's longstanding interest in this very topic. We've held numerous hearings over the last several years and considered two significant pieces of legislation last Congress: the American Space Commerce Free Enterprise Act and the American Space Safe Act. I urge my colleagues to once again please consider these important bills. SSA is an important topic for this committee to consider, but we should do so in a very deliberative manner. Near misses in space attract media attention and calls for draconian regulations, but overreacting could be just as detrimental to our nation's space enterprise. That being said, there are many things we probably all agree on. First, we need better data. The Department of Defense currently operates the lion's share of sensors that inform our understanding of where objects are in orbit, and that will not change. Furthermore, the DoD does not release all of its data because of national security concerns, and that is also understandable. Other elements of the federal government play an important role as well. NASA, and more specifically the Johnson Space Center, which I proudly represent, and the Goddard Space Flight Center are involved in SSA. They sit side by side with the military to monitor satellites and debris in space to ensure the International Space Station and science satellites are safe. But the information the government and private sector are relying on to make sound decisions needs to be improved. Uncertainty about current data is too high, which leads to both unnecessary alerts and unpredicted conjunctions. The second issue that we should all agree on is that the DoD should get out of the SSA business. DoD will always maintain sensors for tracking objects in space in order to protect our national security, but they are not the appropriate agency to interact with the private sector or with our international partners. For this reason, the administration proposed that the Department of Commerce serve as the government's commercial storefront, if you will, for SSA. Commerce can then partner with the private sector, which is something they do well. Commerce already houses the National Institutes of Standards and Technology, the world leader in developing standards, manages export controls for satellite technology through the Bureau of Industry and Security, and coordinates spectrum issues through the National Telecommunications and Information Administration. Commerce also houses the National Weather Service that conducts forecasts and issues alerts to protect life and property, operates a fleet of weather satellites under NOAA, and is the only agency that has statutory authority to license activity in space. Space-based commercial remote sensing. They also have a history of providing a light touch with emerging industries. Commerce stood up the Internet Corporation for Assigned Names and Numbers, or ICANN, through a contract with a nonprofit organization. ICANN was the organization responsible for developing policies, coordinating best practices, and managing the processes that led to a stable Internet. We've already seen the space community adopt a similar approach on our own. Several years ago, operators founded the Space Data Association to share information and to improve safety. The Space Data Association demonstrates how the private sector can collaborate and innovate. More recently, the Space Safety Coalition was established to provide similar capabilities for operators in low Earth orbit. Companies are also providing data and services on the open market. They are developing cost-effective, timely, and accurate SSA data, often relying on off-the-shelf and non-military technologies. In some cases, commercial capabilities are superior to DoD's. This is good news for America and for the global community, and we should help those nascent industries to grow. The third issue that we should all agree on is that we need to develop better standards and better practices. Rather than imposing a top-down regulatory burden on an emerging sector, we should adopt a crawl, walk, run approach. In this regard, the International Agency for Space Debris Coordination Committee, IADC, is an interesting case study. NASA developed its own orbital debris guidelines that were eventually adopted by the entire federal government and then accepted by most spacefaring nations as part of the IADC process. The guidelines are consensus-based principles that inform spacecraft development and operations and could form the basis for developing rules of the road going forward. This could be augmented by contributions from the insurance industry, similar to the role they played in the early days of maritime shipping. I believe that we can all work together, and this will be to ensure space remains a safe environment for future generations without stifling industry with burdensome regulations before they ever launch. I want to thank our witnesses for appearing today, and I yield back, Madam Chair.
Thank you, Mr. Babin. The chair now recognizes the ranking member of the full committee, Mr. Lucas, for an opening statement.
Thank you, Chairwoman Horn, for holding this timely hearing on the situational awareness in space. Only 2 weeks ago, we saw the importance of this issue as two defunct federal satellites, each traveling at 17,500 miles per hour, came dangerously close to each other, 560 miles above Pittsburgh. While there was no threat to those on the ground, the collision in space could have been significant because the debris would impact other satellites and potentially even threaten astronauts aboard the International Space Station, depending on the orbit. The satellites ultimately passed each other without incident, but there were widely varied estimates of their chances of colliding, ranging from 1 in 100 to 1 in 1,000. Limitations on tracking data and the satellite's exact characteristics and orientation leads to this kind of uncertainty, which is problematic. For instance, most of the data on objects in space comes from the Department of Defense. While DoD provides data to the international community and the private sector, national security concerns limit the fidelity of the data it can release. The private sector, however, is emerging as an important partner in this equation. Companies are beginning to provide not only visualization products and services, but also sensor data. Furthermore, companies that operate satellites typically have better data on their satellites than anyone else. Nonprofit groups like the Space Data Association and the newly formed Space Safety Coalition are partnering with government agencies, commercial satellite operators, space data providers, and the international community to provide solutions to the challenge of space situational awareness, space debris mitigation, and space traffic management. The Trump administration is also paying attention. Vice President Pence and the National Space Council released two important policies related to the topic before us today. Space Policy Directive Number 2 calls for a streamlining space regulations, and Space Policy Directive 3 calls for a coordinated space traffic management effort to ensure safety, stability, and innovation in space. The principles in these policies track directly with the positions this committee has advocated in numerous hearings over the last decade. Furthermore, this committee passed two critical pieces of legislation out of the House in the previous Congress that related to space situational awareness and space traffic management. The American Space Commerce Free Enterprise Act, sponsored by Ranking Member Babin, and the American Space Safe Management Act would all go a long way to advancing the development of standards, best practices, and rules of the road in a way that would not stifle the private sector. The administration also proposed giving the Department of Commerce, rather than the Department of Defense, the responsibility to issue notices of potential collisions. DoD would prefer to focus its efforts on supporting our troops and national security. The Department of Commerce already has experience dealing with the private sector to assist commerce. They also license commercial, remote sensing satellite operators, operate a fleet of government weather satellites, protect critical technologies from export, provide safety notifications and forecasting for weather, and understand how to manage technology in a manner that fosters innovation. The Office of Space Commerce and the Department of Commerce is already up and running and has served a similar function coordinating the interactions with the U.S. government, international partners, and the private sector related to global positioning policies. As the host of the Position, Navigation, and Timing National Coordination Office. Unfortunately, our friends in the minority over on the Senate appropriations side are preventing the Department of Commerce from reorganizing in a way that can advance space safety. If we want to seriously address the problem of tracking space debris, advance our space object tracking capacities and develop best practices and rules of the road for operating in space, the first step is allowing the Office of Space Commerce to be the commercial storefront for space situational awareness data. The government can then partner with the private sector and international community to share data and establish consensus-based norms of behavior. This will go a long way to ensuring Earth orbit remains useful for future generations. I look forward to working with my colleagues here on the committee, as well as appropriations, the administration, and the private sector to advance common sense policy solutions related to space object tracking. Thank you, and I yield back the balance of my time, Madam Chairman.
Thank you, Mr. Lucas. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I'd like to introduce our witnesses. Our first witness today is Dr. Brian Weeden, Director of Program Planning for Secure World Foundation, which promotes cooperative solutions for space sustainability and peaceful uses of outer space. Dr. Weeden served 9 years as an officer in the United States Air Force, working in space and ICBM operations, and he directed the Orbital Analyst Training Program that improves space situational awareness as a part of the U.S. Strategic Command's Joint Space Operations Center. Dr. Weeden received a Bachelor of Science degree in Electrical Engineering from Clarkson University, a Master of Science degree in Space Studies from the University of North Dakota, and a doctorate in Public Policy and Public Administration in the field of Science and Technology Policy from George Washington University. Welcome, Dr. Weeden. Our next witness is Mr. Dan Oltrogge. Did I do it right? Okay, I've been practicing, so I'm going to keep practicing. Oltrogge is the founder and administrator of the Space Safety Coalition, which leads the best practices for sustainability of space operations initiative. Mr. Oltrogge is the chair of the American Institute of Aeronautics and Astronautics, AIAA, Space Traffic Management, Space Governance Task Force, and he serves as the International Standards Organization representative to the UN Committee for the Peaceful Uses of Outer Space. Mr. Oltrogge received a Bachelor of Science degree in Aerospace, Aeronautical, and Astronautical Engineering from Iowa State University, and a Master of Science degree in Aerospace Engineering and Astrodynamics from the University of Southern California. Welcome. Our next witness is Professor Joanne Gabrynowicz, Professor Emerita of the Space Law and Director of Emerita of the National Center for Remote Sensing, Air, and Space Law at the University of Mississippi Law Center. Professor Gabrynowicz is also Editor-in-Chief Emerita of the Journal for Space Law. In addition, she is a Director of the International Institute of Space Law, IISL, and is an official observer for the IISL to the UN Committee on the Peaceful Uses of Outer Space. She received her bachelor's from City University of New York and earned her Juris Doctorate from the Cardozo School of Law. Professor Gabrynowicz has also testified before the subcommittee previously. Welcome back, Professor Gabrynowicz. Our next witness today is Professor Danielle Wood, Assistant Professor in Media Arts and Sciences and the Department of Aeronautics and Astronautics at the Massachusetts Institute of Technology. Professor Wood also leads the Space-Enabled Research Group within MIT, Media Lab, which harnesses space technology to address development challenges around the world. Prior to serving as faculty at MIT, Professor Wood held positions at NASA headquarters, NASA Goddard Space Flight Center, Aerospace Corporation, Johns Hopkins University, and the United Nations Office of Outer Space Affairs. She received a Bachelor of Science degree in Aerospace Engineering, a Master of Science degree in Technology Policy, and a doctorate in Engineering Systems from MIT. Welcome, Dr. Wood. Our next witness is Dr. Ruth Stilwell, Executive Director of Aerospace Policy Solutions, LLC, an adjunct professor at Norwich University and a senior non-resident scholar at the Space Policy Institute of George Washington University. A 25-year air traffic controller, Dr. Stilwell now manages a consulting firm offering strategic advice and research services for integration of aviation and commercial space operations. Among other areas, Dr. Stilwell also serves on the Technical Committee on Human Spaceflight Safety of the International Association for the Advancement of Space Safety, which is developing safety guidelines for human commercial spaceflight. Dr. Stilwell received a bachelor's in labor studies at the National Labor College, and she earned a master's in public administration and a doctorate in public administration from the University of Baltimore. Welcome, Dr. Stilwell. As our witnesses, you should know you will each have 5 minutes for your spoken testimony. Your written testimony will be included in the record for this hearing. When you've completed your spoken testimony, we will begin with questions. Each member will have 5 minutes to question the panel, and we will start with Dr. Weeden. Dr. Weeden.
Madam Chair, Ranking Member, other distinguished members of the subcommittee, thank you for the opportunity to testify today on this important issue. Secure World Foundation is dedicated to ensuring the long-term sustainability of space activities so that all of humanity can continue to use space for benefits on Earth. Space situational awareness is the foundation of space sustainability, and working to improve SSA capabilities for all space actors is a major part of our work. As was referenced earlier, on January 29th, 2020, 2 dead U.S. government satellites nearly collided about 560 miles above the city of Pittsburgh. The last actual on-orbit collision between 2 satellites occurred on February 10th, 2009, when a dead Russian Cosmos satellite collided with an active U.S. Iridium commercial communication satellite. The Iridium Cosmos collision generated nearly 2,000 tracked pieces of orbital debris bigger than a softball, most of which will remain on orbit for decades to come. Thankfully, in this latest incident, both objects passed by each other harmlessly at an estimated distance of about 60 feet. Comparing the 2 events highlights what has and has not changed with SSA in the intervening 11 years. The biggest change is the availability of SSA data and who is providing it. In 2009, the only public source of data on close approaches between space objects was the U.S. military's Joint Space Operations Center. By contrast, the first public notice of the incident this past January came from a tweet sent 3 days before the event by an American commercial SSA company, Leo Labs, which operates its own network of ground-based tracking radars that feed into its own catalog of space objects. What has not changed is that we cannot yet predict whether 2 objects in orbit will or will not collide. We can only give an estimated probability of collision, which may change over time. In 2009, the Iridium Cosmos collision served as a wake-up call for the entire space community to the threat that orbital debris poses to active satellites, as well as the importance of SSA for detecting and avoiding future collisions. 11 years later, this most recent incident should serve as an alarm bell that there's a lot more still to do. As a result of the Iridium Cosmos collision, U.S. policy was changed in 2010 to broaden the SSA mission of the U.S. Air Force to provide close approach warnings to all satellite operators globally. This was an important step that has improved the situation, but only so much. SSA capabilities today are dangerously insufficient to deal with the emerging challenges from the growing number of space actors, large constellations, orbital debris hazards, and a more complex and competitive geopolitical environment. The key policy issue still to be resolved is the transition of responsibilities for civil SSA from the Department of Defense to another agency as the first step in establishing a national space traffic management regime. The executive branch has worked on this issue for 8 years across both the Obama and Trump administrations, resulting in Space Policy Directive 3 issued by the Trump administration in June 2018. However, Congress has not yet enacted the required changes in authorities or budget to implement SPD 3 or an alternative, and thus the issue hangs in limbo. Beyond SSA itself, there is the broader issue of implementing a holistic strategy for ensuring the long-term sustainability of space in accordance with existing national policy direction. While the United States has made limited progress on developing orbital mitigation standards, it has made zero progress on developing capabilities to remove existing debris, let alone actually doing so. Neither has made much progress on implementing a space traffic management regime, enforcing debris mitigation standards, or modernizing the oversight and licensing of commercial space activities, all of which relies on improved SSA capabilities. It is critical that Congress act on this issue now. Improving SSA is fundamental to everything the United States does in space and all the benefits we derive from space. This includes protecting human exploration and science, ensuring critical weather and climate data, protecting important national security capabilities, and enabling economic growth and innovation in the commercial space sector. Taking the appropriate policy steps on civil SSA will enable a giant step towards ensuring the long-term sustainability of space activities for the United States, and that humanity can continue to use space for benefits on Earth. Thank you for your time, and I welcome your questions.
Thank you, Dr. Weeden. Mr. I'm going to get it right. Oltrogge, thank you. I will have it down because I've got Professor Gabrynowicz, so next time you're here, I'm going to have it down pat. You're recognized.
Madam Chairwoman Horn, Ranking Member Babin, and distinguished members of this subcommittee, thank you for the opportunity to testify today on Space Situational Awareness, or SSA, and Space Traffic Management, or STM. Responsible SSA and STM are essential to maintaining the long-term sustainability of space activities, space governance, and national security. Why are we here today? It's because the many benefits we derive from space and the welfare of our astronauts, spacecraft, and commercial space industry are all on the line. Today's U.S. flight safety capabilities are insufficient. They produce too many false alarms to be considered decision quality, and the vast majority of lethal objects remain untracked. New capabilities are set to track these small objects, substantially increasing the number of collision warnings. In addition, the U.S. commercial space industry has filed applications for 58,000 new spacecraft into orbit in the next 10 years, 15 times more than any other country, and 8 times more than all other countries combined. The U.S. is all in on the bow wave of large constellation initiatives, an investment that will lead to socioeconomic and technological progress in agriculture, banking, navigation, communications, and Earth remote sensing. So we must ensure the sustainability of space as a vital resource. There are many definitions for SSA and STM as described in my written testimony. For this session, I will use these definitions shown. SSA and STM can help avert situations like the near collision of 2 dead spacecraft last month, which could have produced 12,000 new pieces of space debris. We need to make such headlines go away. Such a large-scale collision would reverberate through our burgeoning $1 to $3 trillion space economy, sowing uncertainty and damaging growth. Left unchecked, the situation may worsen to a cycle of cascading collisions known as the Kessler syndrome, rendering the use of space unsustainable. If we surpass this ecological threshold, there is no return. We've been lucky so far, but the clock is ticking. SSA helps lower collision risks, observing space objects, fusing data and solving orbits, and detecting and characterizing collision threats enables spacecraft operators to mitigate the threat. Today's congested environment challenges operators to understand which conjunctions are too close. The number of false alarms and missed alerts is overwhelming spacecraft operators to the point that they sometimes ignore the warning and go home wondering if they will have a job the next day. True story. The number of objects in space requiring tracking is increasing, a trend spurred by the disastrous Chinese ASAT tests in 2007 and the Iridium Cosmos collision in 2009. Today, we're only tracking an estimated 4% of space debris that can terminate a spacecraft mission. This, along with outdated space tracking algorithms, resulting inaccuracies, insufficient quality control, and a lack of transparency, degrade flight safety. You may be familiar with the space debris situation through the enthralling but inaccurate movie Gravity. Like the film, the depiction at the upper right seems to indicate that spacecraft cannot possibly survive. In actuality, the density of space debris does continue to increase, presenting significant challenges to space sustainability. I have described our legacy of space debris that new space large constellations now inherit and need to operate in. Applications have now been filed to build, launch, and operate over 58,000 more spacecraft within the next 10 years alone. While acknowledging that only a portion of these applications will yield operational spacecraft, we can still expect the active spacecraft population to become 4 to 10 times larger within the next decade. This year alone, The active space population is on track to double. As depicted here, large constellations will experience millions of close approaches requiring thousands of avoidance maneuvers. You can think of SSA as a functional chain. The collective performance of this entire chain determines the actionability of the SSA information. The old adage that a chain is no stronger than its weakest link was in play in the 2009 Iridium Cosmos collision, where a planned maneuver was missed, resulting in a miscalculated collision risk more than a trillion off. These are the basic qualities of viable SSA and STM systems. Paired with advanced astronomics algorithms, actionable notifications of impending threats can be provided. In closing, U.S. SSA and STM services are failing to address global needs at the same time as the commercial space sector is experiencing explosive growth. The lack of a cohesive, properly resourced U.S. space traffic management program places the U.S. at risk of losing this vital initiative to other countries. To avert this, I recommend that you work together to take the 6 actions listed here. These actions cannot be accomplished without the full support of Congress. The long-term sustainability of the space environment, the rich set of socioeconomic benefits of operating in space, and the success of the U.S. commercial space industry are all at risk. The time for action is now. Thank you for your attention.
Thank you, Mr. Oltrogge. Professor Gabrynowicz.
Chairwoman, Chairwoman Horn, Ranking Member Babin, members of the committee, thank you for inviting me here. I was asked to provide a brief overview of the law applicable to SSA, and today that is an amalgam of treaties, contracts, and national law and regulation. A key element of SSA is orbital debris, so I will address the legal regimes and available juridical fora regarding debris. I will conclude by raising 2 crucial SSA issues for which new law is needed: the need to formulate international agreements to establish internationally recognized norms and to prevent small conflicts from escalating, and 2, addressing the gap in United States regulations regarding U.S. private sector activities on orbit. Space is governed by an interrelated collection of space-specific treaties. The first and most important of these is the Outer Space Treaty, and it recognizes that space use and exploration shall be in accordance with international law, including the Charter of the UN. This means that space is also governed by public and private international law and includes international humanitarian law. The Outer Space Treaty also provides that a state party has the obligation to avoid harmful contamination and harmful interference with the use of space. Regarding SSA and debris, the Liability Convention is of particular relevance. It codifies 2 liability regimes: a fault-based negligence regime, which is applicable in space, and an absolute liability regime for harm caused on Earth and to aircraft in flight. Excuse me. An additional set of guidance, but non-treaty based, is the guidelines provided by the Interagency Space Debris Coordination Committee. It provides guidance regarding orbital debris and contains a set of voluntary orbital debris mitigation guidelines, which were adopted by the UN General Assembly. They are not legally binding, but they do provide persuasive authority for addressing orbital debris mitigation. At the national level, orbital debris is slowly evolving as a matter of law. It is specifically addressed in the national laws of Austria, China, France, Japan, and in the United States. In the United States, orbital debris is addressed as part of licensing space-based applications. There are a number of different available juridical fora for the adjudication of conflicts regarding debris and SSA. They include diplomatic channels, which is the first and preferred option, a claims commission that can be established under the Liability Convention, as well as the courts and tribunals and agencies of launching states. And also, of course, if there are any additional agreements between and among states outside of the treaty regime that is applicable to conflict resolution. Recently, formal arbitration has been added to the roster of conflict resolution options through the Permanent Court of Arbitration. However, as a practical matter, these are unlikely to be used either by nation states or governmental space actors. A juridical forum of any kind means rendering control of the situation to the forum. Nation states are sovereigns, and giving up control is anathema to their nature. Additionally, the possibility of exposing acutely sensitive technological and operational information is antithetical to some national interests. There are two issues for which law is still needed for SSA. At the international level, we need agreements to establish internationally recognized norms and to prevent small conflicts from escalating into large conflicts. There is little political will currently for making new legally binding treaties, and recent action indicates there may be declining support for non-binding options. Nonetheless, new agreements, both binding and non-binding, are needed. The issues that must be addressed include the balancing of national security value of data and the need to share data, applicable conflict mechanisms, legitimacy of non-governmental data providers, mistrust issues between governmental and non-governmental providers, and the commercialization of SSA data. At the national level, there exists a regulatory gap in United States regulations. Currently, there's no federal agency that has the jurisdiction to authorize and continually supervise private sector on-orbit activities. And this is occurring at the same time that the United States is planning to increase its reliance on the private sector. In 2015, the Congress required a report from the Office of Science and Technology Policy on how the United States could authorize such private sector activities, and OSTP proposed legislation that would establish an interagency process. To date, due to political forces, this has not yet been done.
Thank you, Dr. Gabrynowicz. Dr. Wood, you're recognized.
Thank you, Chairwoman Horn. Thank you, Chairwoman Horn. And I express my thanks to Ranking Member Babin and to the members of all the subcommittee and the full committee. All of us have the privilege and responsibility to lay a foundation for a sustainable space environment, to make it a safe environment to perform missions without undue risk of harm. In one sense, we are here because space activity brings tremendous social, economic, and cultural value on Earth. I lead a research group called Space Enabled at the MIT Media Lab. Our mission is to reduce barriers to applying space technology in support of a thriving society on Earth and to work towards space sustainability. In a recent keynote speech before the American Institute of Aeronautics and Astronautics, I highlighted the ways that the aerospace industry must contribute to global challenges such as climate change, global economic inequality, human migration, and public health. Space is the perfect vantage point from which we watch our home planet of Earth. As a former member of NASA's Earth Science team at Goddard Space Flight Center, I advocate for the societal value of NASA's fleet of Earth observation satellites. It is clear from satellite data that our civilization is facing several interrelated crises of sustainability that span our oceans, our lands, our atmospheres, our glaciers, and Earth's orbit. In each of these zones, our economic activities deposit unmanaged populations of waste, carbon dioxide in our atmosphere, plastics in our ocean, and objects in Earth's orbit. Our civilization has the opportunity right now to review how we will manage this waste and create a sustainable future. The United States has a leadership role to play in response to this integrated crisis or opportunity of global sustainability on land, in the ocean, in the atmosphere, and in space. Today, I'd like to recommend several policy actions. Number one, the U.S. government should adopt a commitment to space sustainability as a principle driving space activity. Number two, the U.S. government should continue to engage deeply as a leader in international space fora and look for ways to build common vision with emerging space nations. Number 3, the U.S. government should ensure there's adequate funding and mandates allocated to improve space situational awareness and develop concepts related to space traffic management. As noted in the seminal Outer Space Treaty, space is the province of all humankind. I spent much of the last 15 years performing academic research about the applications of space used in Africa, Latin America, and Southeast Asia, and studying their national space programs. Every country on Earth is a space country, but this does not mean that all countries enjoy equal access to the benefits of space. The countries that have been most active in pursuing space activity, including the United States, we are also the countries that have created the most risk for future sustainable space operations. That is why U.S. leadership is so important. We must take an integrated and long-term approach to defining space situational awareness and ask questions about future trends. Where will objects be located in space in the future operations? What are the impacts of currently crowded orbits? What is the demand from industry to use certain orbital regimes? Who are the new players in space? What are the sustainable options for expanding space activities? Our close collaborators in the International Space Station, especially in Europe and Japan, are actively innovating in methods to increase space sustainability through programs dedicated toward orbital debris removal, as well as better understanding SSA and thinking about STM. Ranking Member Babin mentioned the idea of promulgating better practices in space, and one approach to do this is through a positive incentive, not through government activity, but through non-government activity. I'm actually co-leading a team that's creating such an incentive system. It's called the Space Sustainability Rating. An international team is designing this rating that includes the World Economic Forum, the European Space Agency, Bryce Space and Technology, the University of Texas at Austin, as well as my institution at MIT. The Space Sustainability Rating will be a score that any satellite operator can apply to receive. As part of the process of creating the rating, we are engaging with many of the companies that are proposing unprecedented business models to host large constellation of satellites. We hope that governments will join us by promoting this methodology as a way to recognize responsible behavior in space. Here in the US, this work will be particularly relevant to those that are providing review of commercial space operations, especially FAA, NOAA, and FCC. Our activity is really aligned with the 21 guidelines for long-term sustainability of outer space coming out of the UNCOPUOS. As we've mentioned, there's also a need for further thoughts on space traffic management. My research team has performed a study showing the great interest of countries around the world, including Latin America, Africa, and in Eastern Europe, and their desire to be part of the dialogue to design the future STM. So it's beneficial if the US shows leadership by also building strong international relationships with these emerging space players to build a vision for global STM. Thank you.
Thank you, Dr. Wood. Dr. Stilwell.
Chairwoman Horn, Ranking Member Babin, distinguished members of the subcommittee, thank you for the opportunity to appear before you today. Working as an educator in public administration and a researcher in the policy and regulatory aspects of space situational awareness and space traffic management, it is an honor to present some of my findings to you today. Space traffic management as a field of study represents a developing need to prevent collisions between objects in space, both operating in and transiting through shared orbital domains. The reliance on the vastness of space as a mitigation for collision risk is no longer viable given the current demand. The commercialization of space is not new, but its current rate of growth is unprecedented, and without structural change to the manner in which space is managed, the sustainability of the orbital domain is in question, both threatening national space assets and constricting a vibrant and growing sector of our economy. Approaching the policy question of space traffic management as a decentralized safety service rather than a regulatory function can help provide clarity on the appropriate role of the international community, the government, and the private sector. The first question that arises in a discussion of space traffic management is, who has the authority over the orbital domain? Quite simply, how do you regulate it if you don't own it? This is where we find clear parallels to the maritime domain. Safety on the high seas is assured by the application of international standards and agreements enforced by the state under whose flag the vessel operates. This aligns with the continuing supervision provisions of the Outer Space Treaty. It does not rely on one authority, but rather on the agreement of the seafaring nations of the world to enforce agreed-upon standards. While we consider the prevention of collisions in space when we discuss space traffic management, the sustainment and protection of the orbital domain includes issues that go beyond tactical collision avoidance and have additional parallels to international maritime operations. Debris, contamination, and salvage affect both domains, and we can look to maritime law as a model. Debris mitigation and remediation guidelines to prevent major debris-generating events require international agreement to be sustainable and effective. By dividing the concept of space traffic management into its component parts, the policy framework and appropriate structures become more clear. The foundational element, space situational awareness, provides the information infrastructure upon which the safety regime can be built. This includes the detection, collection, and dissemination of information on the location and trajectory of natural and man-made objects in space. There are many sources of data, including space surveillance, observation, and operator data. Built on top of that is the Conjunction Assessment and Alerting Service. Currently, both services are provided by a single entity through the U.S. government, but we are already seeing commercial providers. This clearly illustrates that there is a path to a decentralized model for space traffic management. However, this will not occur organically. The transition from a service provided by the United States military on a no-cost basis to every satellite operator in the world to one where there are multiple providers who can provide conjunction assessment and alerting services tailored to the needs of individual operators requires a structured transition with deliberate oversight. The steps needed to build a decentralized STM include, 1, the international agreement on standards of behavior for the purpose of collision avoidance. This is a government function that cannot be delegated. The creation of standards and best practices can and should be driven by industry, but transforming those standards and best practices into an international agreement is the role that only governments can fill. 2, processes and agreements for the collection, validation, and sharing of space situational awareness information, including space surveillance and operator information. This is a joint effort between government, industry, and academia to create a robust system that allows for inputs of space situational awareness data from multiple sources, including the intent data from operators. And finally, the expansion of a market for conjunction assessment and alerting services. Under the current model, hundreds of thousands of conjunction messages are generated every year, resulting in only a few hundred avoidance maneuvers. The industry bears an enormous cost in evaluating these assessments. A competitive commercial market incentivizes investment in analytics tailored to customer needs. This is not a unique concept. It bears a lot of similarity to the National Weather Service and the GPS models. In both cases, services built primarily for government purposes are provided to the private sector and support a robust and innovative commercial industry. Using these models can provide a path that allows for the transition from the current state to a decentralized global model that ensures a sustainable space environment. I thank you for your time and attention to this important issue, and I welcome your questions.
Thank you, Dr. Stilwell. And thank you to all of the panelists for your incredibly detailed and comprehensive and important testimony that really touches on the wide variety of issues. At this point, we'll begin our first round of questions, and the chair recognizes herself for 5 minutes. Given the breadth and the depth and the scope of the issues that we're facing, I want to start out by asking all of the panelists this question that, while many people are while there are many of us that are eager to settle the questions about U.S. agency roles, public, private, what is that right balance? And we'll consider some more of those as we carry out our work. I think further identifying the scope and prioritizing the order of addressing the solutions is something that we need to start with. And I'd like to ask each of you, and we'll just go down the line, to briefly identify the most pressing issue and how you would propose to address it. So we'll just start with you, Dr. Weeden.
Thank you for that. My most pressing issue is the policy question. That's partly because I'm a policy wonk, so I think that's what I focus a lot of time on. But I currently think all the other issues on improving the technology, improving the coordination, all hinge on that policy question. So for me, the most important thing is that transition of the civil SSA responsibility to wherever it's going to go, and making sure that happens in a smooth manner, as mentioned by other ones, is the most important thing. And I believe all the other issues on improving the accuracy and collecting more data and better data fusion and sharing and collaboration all flows out of that decision.
Thank you.
Yeah, thanks for that question. It's going to seem like I'm giving two most important things, but it's really one. It's transitioning to an entity that nurtures and facilitates commercial innovation and better algorithms. This is something that we have not made good headway on, and I think that's crucial that we get that going, and as I showed in my presentation, we need to get going now. Thank you.
Thank you.
I believe it's going to be crucial to have an interdisciplinary response to SSA. I think we absolutely need international agreements to address a lot of the things that the panel said, but that has to rest on a bedrock of agreed-upon technical standards and the acceptance of providers to provide the data. And so there needs to be an interdisciplinary approach in which the technology is the foundation for implementing the policy and the law.
Thank you. Dr. Wood.
Thank you. I would like to actually sort of echo and repeat many of things the other panelists said. So what I'd like to add is the idea of having integrated cross-agency commitment to the various needs, whether it's looking at improving research in academic setting and making sure it's funded so we can bring in new technology and new workforce at the same time as having new operational activities. So I think what's needed is coordination across agencies.
Thank you.
I think it's clear that the first step needs to be establishing who is the lead authority for the government in advancing this work forward. When it comes to international agreement, that clarity is essential. And there is a lot of work going on in a lot of different places. Without a clear understanding of which agency is the lead agency, I think we will not make progress.
Thank you very much. And following on from that, I think the critical question is addressing the patchwork that we have identified as part of the problem of international coordination, federal regulations, debris mitigation, all of the things that have been addressed. And I'm going to ask this for all the panelists. We'll just go back in the other direction, so you get to go twice in a row, Dr. Stilwell. And I think it's interesting to look at other similar answers to this question. I'll be very quick about this. Maritime as a model, and how do we move very quickly from this patchwork to create a holistic framework? Is it along the lines of the OSDP interagency process to identify, or just very quickly, because I don't have much time left?
I'll try and answer quickly. If that model is adopted, there are agencies that are experienced with it. The movement to commerce lets them follow models that already exist. So there's technical expertise within the department in how to bring in the industry information, developing it into international technical standards, and moving forward to international agreement. So the way you move quickly is assign the duty to those who have expertise in that area.
Dr. Wood.
I just want to repeat the same idea that one of the key opportunities is to see where expertise has been developed in small communities within many agencies, and to make sure that it is not lost in transition periods.
And whoever is chosen to be the lead agency, they have to have in-house capability commensurate with the task. And right now, there is no one agency that has it all. They are going to have to, they can be the lead, but they're going to have good working relationships with other agencies and space expertise. NASA comes to mind. They're not a regulatory agency. They can't do it, but they've got to be in this loop.
Thank you.
Yeah, also to sort of reframe what Dr. Stilwell said, there are existing frameworks out there. It behooves us to take advantage of those and get moving. But one of the studies that I led for AIAA was a space traffic management governance study. What's out there? And what I found was really fascinating. There is a fabric, a continuum of space governance out there people like to say, what's the right answer for a certain thing? But what I've found is that there's many instruments out there, and we need to get comfortable with employing all of those instruments, I think, to get to where we need to go. Thank you.
Thank you.
So I just want to echo and reinforce that point, a point I made earlier. There are multiple potential answers. There is no agency that stands out as the clear favorite. There are several possibles, all have pros and cons, all could probably work. That makes it a little bit harder because there's no clear answer. And the same thing with these models. We have all written papers comparing space to maritime or space to air traffic or space to weather or GPS sharing. And there is a little bit of analogy there, but it's also a little bit different. So again, there is no one clear answer that fits we can just copy. We're going to have to pull the best parts from each one of those.
Thank you very much. I'm well over my time. Recognize Ranking Member Lucas for 5 minutes.
Thank you, Madam Chair. And listening to those last responses, I'll turn to you, Dr. Stilwell. As a former air traffic controller, let's talk about whether we adopt for the space sector the air traffic control model to emulate or the maritime domain. Expand on, if you would, as being valuable to study, I guess is the way I should word that.
I'm happy to. So there's significant differences between air traffic control and the concepts of space traffic management, the most significant of which is that air traffic control is predicated on a single entity having authority over a physical volume of airspace. And that does not exist in the space domain. That brings rise to the maritime comparisons, where there are multiple authorities responsible for operators within the domain. So there are issues in air traffic control that are very useful and very instructive, and that is particularly in the way that international standards are reached through the ICAO process. That without reaching new treaties or new agreements, new technical standards can be adopted by the world. And what we see in the ICAO process, which I would like to note, seeks consensus, but is not a consensus-based process. It is an industry expert-driven process to reach standards that can be implemented by all nations in the world. And what we see is that when ICAO is able to develop guidance material, it is adopted because that material is valuable. It saves each individual country from trying to develop their own standards. So the value occurs long before we reach an enforceable standard and at the guidance material level. So if we use that model, bringing in the industry expertise to develop what starts as guidance material and evolves into a standard, we get a jump start on the process for reaching those international agreements. For us to develop behaviors in space that are applicable only in the U.S. or only in the U.S. or Western Hemisphere countries doesn't get us where we need to go in terms of space situational awareness and space safety. So there are instructive models, but it is not a plug and play. We cannot say, let's do what we do with air traffic control, because the environment in the governments is dramatically different.
Several witnesses, Dr. Stilwell, discussed the challenges that DoD faced upgrading their SSA systems and software. And despite considerable taxpayer funding in many years, they're still using the same system. Your testimony highlights how the private sector is much more innovative and can adopt new challenges more quickly. How could a distributed governance model for space situational awareness allow operators of space assets to become customers of data rather than simply users of data? And please elaborate on the importance of this difference as it pertains to innovation and the burden on the taxpayers, I would note.
It's quite important because the Stratcom is very competent at fulfilling their mission, which is to protect U.S. assets in space. And they develop their systems to do that. The ancillary benefit to the space community of providing conjunction alerts is an additional service that's provided, and it's not intended to be tailored to meet a specific satellite operator's needs. Nor should it be. As you mentioned, the taxpayers have no obligation to fund specifically tailored services. By dividing the two elements, the space situational awareness, where the infrastructure of data about the location and trajectory of objects in space, and the conjunction alerting services into two separate functions, we have the ability to use the infrastructure as a joint use infrastructure, as the same as we do with radars and navigational aids on the terrestrial domain, and allow the industry to use that data to develop more bespoke tools. You become a customer when you are paying for a service. If you are, there's a high cost to a free service, and the industry is experiencing that high cost in their cost of evaluating hundreds of thousands of conjunction alerts. If we allow a healthy, competitive industry to develop in this layer between the operator and the infrastructure, then there is an opportunity to innovate quickly, and in a competitive environment, there is an incentive to invest in the analytics to provide more precise information to those customers. There's not an incentive for government to invest in that because it is not the priority under the current model. The priority under the current model is to protect U.S. space assets in space, and STRATCOM does that very well.
Continuing with you, Doctor, in your opinion, are the problems of orbital debris, space situational awareness, and space traffic management, would you describe them as data issues or behavioral issues? And as you think about that, I guess I would ask, are most operators good actors?
It's a combination of the two. Better data gives you better information so that you can make better decisions. So the question of whether it is a data issue or a behavior issue is not, they're not divorced partners. Your behavior is based on the data that you have available. However, in the question of good actors, you can only be a good actor if you have rules to follow. We can't expect someone to comply with a rule that doesn't exist. So when it comes to particularly a conjunction between two maneuverable satellites, who executes the maneuver is important because there's an economic cost to executing that maneuver. It reduces your emission life of the satellite, and companies should not be expected to be altruistic in being good actors. They should be expected to follow the rules. However, without any rules, it comes down to a negotiation, and we should not expect two commercial enterprises to ask each other to sacrifice their viability in the absence of any structure. In both the maritime and aviation domains, we have right-of-way, and that answers that question for you. So the fact that you're a good actor does not negate the need for good rules, which we do not have.
Thank you, Doctor. And my time has expired, Madam Chair.
Thank you, Mr. Lucas. The chair recognizes Mr. Byer for 5 minutes.
Thank you, and thank all of you for being here today. This is my 6th year on the committee, and we have often had glancing blows about space debris. This is really the first time we've really gone to the experts to really understand what's moving on it. So thank you very much, and Madam Chair, thank you. Mr. Oltrogge, you talked about the Kessler syndrome and the chain reaction effect, and specifically about the ecological threshold, the ones past we cannot return. Even in a nuclear fissile thing, when there's a chain reaction, it gets to the end of the chain reaction. What would happen if you don't get back to the way things were? Well, what's the space look like, or the world look like?
Yeah, so Kessler syndrome, basically people put out that it has, it goes chain reaction, and it just keeps going. Fact is, it will reach some sort of stability point. The real issue with that stability point is by the time it does, you have a huge number of small particles out there, and fragments. Overall, space debris population are quite large.
So many of the existing satellites will be taken out.
Yes, it puts satellites at risk. We are globally and in the commercial innovation market, we are working to track smaller and smaller things. There is a construct that operators today have when they fly their satellite. They look for information on what's coming close to them. The population, as was mentioned earlier, is about 22,000 objects, 23, of publicly released objects. That could grow by a factor of 10, as I mentioned.
So let me pivot to Dr. Weeden, because you talk about active debris removal. We see that we're talking about carbon capture here all the time in terms of carbon in the environment. They got rid of the trash. They're trying to get rid of the trash at base camp at Everest. People are trying to collect the plastic from the ocean. Why do you think NASA and DoD have been so reticent to develop ADR technology?
Flight, but it's not their job. So 2010, the Obama administration issued a national space policy that directed both NASA and the DoD to jointly develop the technology. But it is not a core mission area for either organization to manage the space environment or to remove space debris. And so when they put it up against all the other priorities they have, from all the things that are in their mission statements, they've been directed by Congress to do, it emerges an unfunded mandate. And there is not that organizational interest in taking care of it.
So which organization should do it? Perfect world.
So that is, like the question we were discussing before about SSA, there are a couple of options. NASA could do it. My sense, though, is that it would be overwhelmed by all the other things NASA's focused on: Moon, Mars, science, all those things. I think in a perfect world, I would probably marry this, what I'll call Space Environmental Management mission with the Space Traffic Management mission and the SSA mission, because they all share and overlap a little bit. Now, that does not mean that a government agency should be the one removing debris. I think there's a lot of room for the commercial sector to do there, but you should have a government agencies providing oversight of that and helping incentivize that.
Yeah, great. Professor Gabrynowicz, you're the first person I've ever met that has a satellite named after them, or an asteroid, rather. In politics, we get bridges and schools and stuff after we're dead. But
Mine is an asteroid.
asteroids is very cool. But you talk about the now stalled draft code of conduct for outer space activities being stalled, and we look and say we can't ratify the International Criminal Court or the law of the sea, or how are we going to, why is there so little interest, not just in the United States, but globally, for these binding, seemingly necessary treaties?
I think there's two answers. One answer is that we are dealing with topics that do by nature involve the entire globe. So that makes it difficult for individual nations to understand truly what their responsibility is and what they can afford to do. When you talk about the climate, when you talk about the oceans, no, that's bigger than any one nation can handle. And we're trying to figure out how to allocate responsibility. The second answer is, I think, and this is more the law professor answer, is I think we're at a time where the nature of legal agreements is changing. It's like the early 1600s where the treaty appeared for the first time. Before that, there were no such things as treaties. Treaties came into being because we needed them to come into being. It was the kind of agreement we had to do because nations were beginning to interact with one another. And in fact, the nation state as we understand it today didn't exist till then. There's something going on now globally where with the constant shift of political power and economic needs and shifting borders that is going to require different kinds of agreements. And we've been doing that since the end of World War II. We have declarations of principles, codes of conduct. There's all kinds of agreements that are trying to satisfy the needs that the formal treaty process has been able to satisfy for a number of years, and we're still working on it.
Well, thank you for painting the picture where we need to go. And I yield back, Madam Chair.
Thank you, Mr. Byer. Chair recognizes Mr. Posey.
Thank you, Madam Chair, for holding this hearing on the challenges affecting the current space situational awareness program. The President's Space Policy Directive 3 is a policy to improve the SSA and space traffic management through broad interagency coordination. One of the goals is to transfer the space debris repository from the Department of Defense to the Department of Commerce. So hopefully DOD can focus on its mission of protecting the United States and our allies, and the Commerce Department can focus on space debris with the expected launch increases. Part of this process involves setting standards. The National Institute of Standards and Technology is currently working on the best practices to encourage space safety and innovation. That's a really good thing. And according to Mr. Kevin O'Connell, Director of the Office of Space Commerce of the Department of Commerce, these new standards are in part key to making sure that the United States remains the flag of choice for space entrepreneurs. I think we all want to do that. Dr. Stilwell, with the number of launches expected to increase this year, space traffic management is important to our space program and vital to our national security. How do you think SPD 3 will allow for more launches to occur in a safe manner?
In my experience, SPD-3 has been very well received by the space community, and that there is a lot of enthusiasm for those concepts to move forward in order to facilitate growth and action. It's important that as we talk about debris mitigating behaviors and active debris removal, that we not set new entrants up for a situation where they're designing a launch that doesn't meet standards that will be developed shortly after, or even years after. If we can develop those standards early, we support that industry, we support that growth, and we create an environment where people know what their target is. As specific questions about end-of-life access, so that we don't have two dead satellites that are heading towards each other, that honestly, having better data about their collision doesn't make the system safer. It just makes us know better that two non-maneuverable objects might collide. What we need to do is reduce the number of non-maneuverable objects that remain in space. And as a design function for the industry, they need to know what that expectation is. So there are a number of elements within SPD-3 that set us down the path to giving predictability to a growing industry, and that's a very important part to support industrial growth.
If you just had to guess, what do you think some of the suggestions would be?
The 25-year rule is a very long rule. That's a long time to leave your objects in space. It doesn't take advantage of the technological innovation that has occurred since that rule was put into place. How you deorbit your satellite at end of life, there are a lot of more options now than when those concepts were developed. Those are important. And also the removal of large objects. There may be a very clear path that says you have an obligation, if you leave a large object in orbit, for the future active debris removal when that becomes available.
I would hope that we would see that. Do you think it's realistic to require internationally that every single satellite that's launched have a solid plan for how to deactivate that satellite and remove it from space?
I do think it's realistic. And the interest of the international community is the same as ours. Often in the space discussions, people say, well, would China do this? China, as an emerging spacefaring nation, has the same, if not a growing interest in ensuring the sustainability of space. There is an interest from every country that wants to be able to exploit the opportunities that space provides to ensure that that is available, that it is not a high-risk environment. So the beauty of working in the space industry is it tends to be nonpartisan and non-controversial. We want a lot of the same things. The international community wants that as well. Okay. We don't have these conflicts where people are saying, no, let's do nothing. Everybody wants somebody to do something, and the U.S. is in the perfect position to take that leadership role.
That's great. I hope we do. Thank you.
Thank you very much. Chair recognizes a gentleman from Colorado, Mr. Perlmutter.
Thank you. It's a busy afternoon, so I missed a couple of the questions. But just sort of piggybacking on what you and Mr. Posey were just talking about, Professor Stilwell and Professor Gabrynowicz, these questions are to the two of you, because I'm really trying to understand the legal framework here and whether the law of the sea is actually expressed in any of our treaties, and how, if it isn't, how we get there to put some kind of structure in place. You say everybody wants to do something, but we also know that there's national security issues. You know, we've got some satellites up there we don't want anybody to know about, or, you know, technology within it. So how would you both suggest we get to a framework, and I think you both talked about debris contamination and salvage, that might otherwise be expressed in the law of the sea? How do we get from here to there?
First of all, let's reach an agreement on salvage. Right now, there is no legal right to salvage in space, and there's a very good reason for that, and that's because when the treaties were being negotiated, neither the Soviet Union nor the United States wanted to give the other party an excuse to grab their space object and reverse engineer it. So salvage...
But don't we still have a little bit of that problem today?
You asked for a legal answer.
Okay, all right.
Okay. Remember, even during the height of the Cold War, We reached agreements with the Soviet Union because we had to, because it was in both our interests. We would not have space law today if the Soviet Union and the United States didn't agree on the treaties. The confidence building measures like the hotline agreement, we can do those things. If we could do that during the height of the Cold War, there's no reason why we can't do those things now. All we have to do is find things where there is common interest and then get serious about putting the political will behind it. It's not all about, you know, hugging an airy-fairy and all that kind of stuff. It's pragmatic. We
All right,
need to
so
save our
Does
satellites.
somebody have to call to convene a treaty conference? Is that where we are? Is that what needs to be done? Or can we do it one-on-one with China, one-on-one
You
with Japan?
can do it any way
one-on-one-
you think the avenue is going to work for you. If I were queen of the world, I would say which avenue is going to be the most productive. I think the beginning of the most productive is you talk to nations who have as much to lose in space as you do. And then you sit down and say, look, let's stop blaming each other for the moment. But the debris caused by the X incident and the Y incident are things we can't do again in the future if we both want to continue our space program. So let's create some rules of the road.
So, Professor Stilwell, does NASA convene this? Does the International Association of Insurance Agencies convene this? How do we get this going? Because everybody on this panel seems to be of one mind about we better get busy here.
This is the State Department function. It's international diplomacy. And Professor Gabrynowicz gave a good description of mutually assured destruction. And that's a powerful motivator. And we have that in space right now because if the space environment becomes unsustainable, there are tremendous costs for not only the spacefaring nations of the world, but as Dr. Wood pointed out, every country is a space country. So the UN Office of Outer Space Affairs has the Committee on the Peaceful Uses of Outer Space. They have mechanisms available. What we need is the political will to start moving this forward.
And you would suggest that the law of the sea is a common denominator, something that we're all comfortable. The world, is comfortable with the general parameters of maritime law.
And it has evolved over hundreds of years in a very constructive way and illustrates that even if you don't have a ratified treaty, countries comply with the provisions. And that's an important element as well.
And may I add, if you read The Shadow War, James Clapper also says we need the law of the sea for space, and a number of his colleagues as well. So it's there.
Okay. I thank you all for your testimony today. I think you have made an impression on certainly me, and I thank you. And I yield back.
Thank you. The chair recognizes Mr. Olson.
I thank the chair and welcome to our 5 witnesses. Well, low Earth orbit is getting real crowded, huh? This SSA and STM started on October 4th of 1957 with the launch of the Sputnik 1 satellite. Now, challenges there because she was powered for maybe a week or two, came down after 21 days, no collision chances up there in orbit, but that started then. Right now, though, that world has changed, as y'all know. We have over 9,000 satellites up there orbiting right now. Almost 2/3 are dead, out of fuel, missions complete. 1/3 are actually viable right now. We do have an idea what happens if we have a collision. Intentional collisions with China, anti-satellite missile firing, and I guess it looks right around 2007. Our debris in that graph you put up there, Dr. Weeden, doubled almost overnight with that missile shot. That was intentional. Y'all scared me pretty earlier talking about the crisis over Pittsburgh, Pennsylvania. Those 2 satellites coming at each other about 32,000 miles rate of closure came about the width of this room from a collision. 500 miles over Pittsburgh, Pennsylvania, almost have a collision the size of this room. That meant catastrophic. Having grown up about 2 miles to the Johnson Space Center. My main goal is to make sure that those human beings who've been there now for 20 straight years on orbit every single day do not have any impact from some satellite debris, that we control their safety. And it's not just for America. We are now the world's space travelers. China's doing a little bit, both us, Russia, ESA, we are dominating spaceflight to the entire world. And so I want to make sure we're proactive instead of reactive with this debris field that's growing. That means SSA is proactive. That's what we should do. STM is kind of reactive. And so I think nothing helps us more with being proactive than artificial intelligence. I'm the co-chairman of the House AI Caucus. And so my question for all of you is, what role does AI play in the world of SSA? Dr. Stilwell.
I am not an expert in artificial intelligence, and I think it's only responsible to defer to those who are.
Dr. Wood.
Thanks so much for the introduction and for the questions. I want to highlight one of the things we've been discussing is the practices and what it means to have healthy practices that reduce the uncertainty. So those begin actually during the design phase of a satellite before it even goes to space. There are actions that operators can take, including how they use tools like artificial intelligence to understand how they're going to be the best operator they can, how they're going to know where their satellite is, share that hopefully with their own government and with other operators through groups like the Space Data Association. Then some teams are interested in using artificial intelligence to help figure out how to operate their satellite. It's actually an emerging technology, and it's interesting, but it also creates confusion, meaning if you operate your satellite and you use an algorithm partly informed by artificial intelligence to plan when you want to maneuver from one orbit to another, that could be interesting technically, but it also creates more uncertainty for other operators around you to know where you're going to be at a given time. So actually, I think it's an open academic research question and operational question. But certainly, we do, as the space community, want to take advantage of the benefits of these tools. But I think overall, we want to say operators should be incentivized both by government requirements as well as by peer pressure among the commercial community to do what they can in the design phase and in the operation phase to be as transparent as possible. That means better communicating where you are, and better having the right physical objects on your satellite so you can track yourself. We need to be able to identify and track objects. But we can also use artificial intelligence as we try to understand the complex behavior of satellites in space. So multiple answers.
Thank you. Ms. Gabrynowicz.
Remembering I'm a lawyer and not a scientist, I agree with Dr. Stilwell that you need to ask AI experts, but from a legal perspective, two of the most important things you're going to have to deal with if you're going to be using AI is intellectual property rights and liability.
Mr. Oltrogge, if I pronounce that.
Thank you. Yes, you did. Let's see. I'm a person who feels that a holistic approach is very important here. We have to try and address the threat of space debris through all avenues. AI is a very important one, and I think it needs to be a heavy area where we do research. The issue, though, is a lot of the data that would feed that AI, I feel today is not out there, and it's just not to that level yet. So all across, we need to pursue.
Thank you. Dr. Weeden.
Yeah, I just want to echo what Dan said. Say the thing. A lot of what we call AI is actually machine learning algorithms, and they're essentially only as good as the data you feed them. And to echo what Dan just said, we don't have the underlying data in a point where we have enough of it. We understand its precision, its accuracy, its confidence. We don't really understand it at the point where I would feel confident to feed that into an algorithm at this point in time. So I think we start with fixing the data, get a better handle on that, and then, yes, I think we're going to have to move to an area where we adopt things like machine learning, other things to help improve the situation.
About time. On behalf of our chairwoman, can y'all say hook 'em? Anybody?
I'm from New York. No, sorry.
I yield back.
I thought you would have learned your lesson, given that you still owe me a bunch of tamales. So, you know,
They're
eventually.
coming.
Okay, I'm holding you to
La
that.
Casino.
I'm ready. Well, thank you all so much, the witnesses. This has been an incredibly informative and helpful hearing, I think, to lay out the expanse of the challenges we're facing. And we're about to wrap up. There's one small question I want to close out with, because there's much more that we'll follow up with. But the 25-year rule that was just discussed, I want to circle back on that because. And Dr. Wood, I'll direct this to you, and if anyone else has anything, we can add to it. But there was recently, in December of 2019, there was a NASA-led interagency task force that talked about updated standard practices that still included the 25-year rule, which seems to be very counter to all of the things that we've been talking about here. So I'd like to hear from you what the impact of these standards are going to be likely on the space community, and how widely they're being adopted or perceived.
Thanks so much for the opportunity. You know, I think one thing we haven't done enough today is talk about how there are different ways to operate depending on which altitude you're in space. And so we should think about how we might require or expect different behavior from operators somewhere in the 400 to 600 kilometer location, which is very popular for certain low Earth orbit missions, versus the medium Earth orbit regime versus geostationary. So I think we really want to target our advice or our behavior expectations depending on where you are, and ask what's been historic usage of an area. And not just are we going to have the Kessler syndrome, but is that particular altitude of particular interest and popularity, and therefore it requires special concern and special rules. So of course, with our space sustainability rating, what we're trying to do is actually encourage operators to do better than what's required by current laws. So we would hope, even if a government requires 25 years, that they would see it as actually a commercial benefit to perform better, to actually get their satellite out of orbit, especially if they're in an orbit where they are known that they're sharing it with a lot of other commercial operators. So as part of what we do is we calculate both how popular is that orbit, how much has there already been a use of that orbit, and that's drawing from the techniques developed by the European Space Agency partners. And then we ask what will be the likely benefits of removing your satellite from that particular orbit, not in general, because that orbit is popular or because there's already a lot of satellites there. So when we ask what's the importance of removing your satellite, we should also ask what's already been happening historically in that orbit, and why is it so important that your particular mission will make room for future missions in that orbit. But I do think there's an opportunity, and there's a lot of consensus among the technical experts, that it is feasible to remove satellites faster than 25 years in many cases, especially in orbits that are already popular, that already have historic laden with debris. And so therefore it behooves us, both by voluntary choice as well as by government action, to really move toward shorter times in orbit beyond the mission lifetime. Thank you.
Yes, Dr. Gabrynowicz.
Again, speaking as a lawyer, I have no opinion as to whether 25 or some other number of years makes a better rule, but I will say we call it a rule, but it's not legally binding. The only entity who is legally bound by the 25-year rule is NASA. Unless the 25-year rule goes through the APA rulemaking process, it is not binding on any other federal agency. Other federal agencies have said, we will try to abide by this, but there is no legal requirement that they do so. And there certainly is no requirement outside of the United States for anybody else to be bound by the 25-year rule. And if you change it to 5 years or 10 years, that's still going to be the situation.
Go ahead.
So I'm a founder of the Space Safety Coalition. We have 37 space organizations who have joined to develop best practices and also align with international best practice, but develop our own aspirational ones over and above what the international consensus and documents are. So orbit lifetime there, aspirationally, we seek in that document to be done in 5 years. Get your satellite out of orbit 5 years, within 5 years of the end of your mission. So aspirational in the commercial arena, where operators do want to do the right thing, is a very powerful thing, in that in advance of international consensus, the commercial operators and companies can strive to do better. So that's I think, a very positive thing. In terms of the 25-year rule itself, developed in 1995 based on the then population and the then analyses that were done. That was something that was seen to be a reasonable compromise between the cost of immediately bringing your satellite out of orbit versus leaving it up there forever. So it's a compromise. The ODMSP that was just released last year, 2019, does something interesting in that it still requires a 25-year rule, but it aspirationally adds, hey, we should take these satellites out of orbit as soon as we can. Thank you.
Quickly, just to add on that, I want to touch on the point that was made about not having a blanket rule for everything. I think that is the regime we should be thinking about. Instead of 1, 25, 15, whatever, everything, we need to think about a tailored approach to different orbital regimes because they are different. The second is to talk about enforcement. At the moment, the European Space Agency is the only entity I know of that's monitoring who's complying with this. It's roughly around 50 to 60% compliance with this existing 25-year rule or suggestion. That's good, should be a lot better. So better enforcement it's going to come through national legislation, national policy is where it needs to be, as well as thinking about less of a blanket rule, more of a tailored approach.
Thank you very much. Would you like to contribute to that? Okay. I'm happy to, if you'd like, it's fine. I want to say thank you again. This is incredibly important and informative and further identifies the need for us to move quickly, to take action, and highlighting the multiple layers of challenges and the need to be intentional and tailored in the way that we address this, using incentives, some regulations, other voluntary, commercial. I think there are many different layers to this that can help us to address these issues. You have all touched on many of those areas, and we're very grateful, and we'll continue. Before the hearing closes, I want to make sure that we note that the record will remain open for 2 weeks, and for any additional statements from the members or any additional questions the committee might ask, I can almost assure you that we will have additional questions for the record. So we be prepared for those. But again, this testimony was invaluable. I thank my colleagues on both sides of the aisle for the importance of this issue, and the witnesses are excused. The hearing is now adjourned.